This video aims to identify the most important QTL combinations to provide resistance towards MLN. Dr. Francis demonstrates the first step, including data merging between the adjusted means generated from the previous video or video part 3 and the hypothesis group data. Subsequently, the data was analyzed for the significant effect of each model parameter through analysis of variance. He also demonstrated steps to conduct a mean separation analysis and discussed the importance of choosing a data visualization approach. The conclusions from the overall lecture is also included in this video.
What I want to do now is read in another file. I want to read in my link file that has the treatment linked to a hypothesis group. Okay, so the hypothesis group, treatment hypothesis, is basically telling me what QTL are there. All right, so I'm using this line to merge these two sets of data so that now I have my adjusted means associated with what actually the QTL are. And I can visualize that. Now I can just run a straight ANOVA on the adjusted means versus that treatment hypothesis. And there's really two ways of doing that. I can use the linear model function, right? Or I can use the AOV function, and I can compare them. They in fact, because it's a balanced data set, there's no missing data, they give me the same result. The advantage of using AOV is that I can now use this to do some mean comparisons if I want. Now, I also want to just point out a slight variation in the approach that I've used here, because again, if you pay attention to this sort of thing, it helps you later to master coding in R, as it will. So here, I'm using this dollar sign, so data x dollar sign. So basically what this is saying is I want the variable called mean.adjusted that's in this data frame, right? And I'm comparing it to this variable within that same data frame. Here, instead of writing data x dollar sign here and here, I'm just telling it here data is data 6. Okay, so this is actually easier, right? Another thing I could have done is just attached data 6 and then ignored it altogether. So 3 different ways of accomplishing the same goal. Jump down here, the results of my analysis of variance. So what is the conclusion here? So it matters what QTL you have. It doesn't tell us which ones are important, it just tells us that it matters. So the next step is to say which ones are important. If I'm doing a weed science study, my original treatment groups could be rates of a bunch of different chemicals, but then I could merge my adjusted means based on the class of chemicals as an example to see if certain chemical classes are more effective. Just trying to make sure you understand that this isn't only relevant for people that are interested in the genetics. Okay. Notice that if I use instead of a linear model, if I use AOV, that I get the same results. So the only time you won't get the same results is when you maybe have missing data, or maybe very unbalanced designs could give you differences as well because of how the denominator degrees of freedom are estimated. Okay. There's an LSD test function that's supported that can be used to run a mean separation. Okay, so if we apply that to our model, remember this is what we created with AOV, we can generate a mean separation. Basically end up with mean comparisons in different groups, right? And so what we see is that our susceptible checks have very high AUDPC. When we add just 10, it's significantly lower, equal to our resistant check. 10 and 6, numerically lower but not statistically. 6 alone, numerically lower but not statistically. 3 is statistically better than our resistant check. 3 and 10, better yet. 3, 6, and 10. 3 and 6. It looks like 3 is a pretty important QTL, right? And 3 in combination with either 6 or 10 is pretty important. So this little pilot experiment gives us some indication that having polyvirus resistance in the maize germplasm may in fact help against MLN, and it tells us which ones that we should really be concentrating on. 10 is the least important, 3 and 6 are more important, and a combination is important. So data visualization, we can use bar group again to graph this out. We can add error bars to it. So there's a graph bar group where we've got our mean separation. We can add error bars, so we see really what kind of variation is there in those. Take you back to the box plot. Remember the good old box plot? There's a video at this URL that's kind of amusing to watch. All right, but it brings up an important point about. So I'm a big believer in data visualization, but I also realize that you can fool yourself by how you put together data. Okay, so I think that bar plots for this data set are actually perfectly acceptable, but the example that they use in the Kickstarter campaign is actually quite insightful. And the gist of it is that somebody surveyed animal size, cat and dog size, near a zoo in Sweden, and they concluded that there was no difference between the size of the cats and the size of the dogs. But it turned out that their survey included the cats in the zoo. And so they were averaging really big cats with house cats to come up with a mean that was the same as the dogs. But if you actually looked at the distribution of the data, the cat data had a bimodal distribution. And so actually making sure you understand what goes into that distribution is important. And so again, the point is that we have different tools. We can use the bar group approach, we can use the bar error approach and look at the error, but we can also go back to our box plot approach to kind of look at distributions. It's kind of important to understand how these distributions shift. And there's really nothing here that makes me worry about the conclusions. These points are kind of outliers for some reason. So one that's really more resistant than the mean, one that's really less. There's a low outlier here. But overall, I don't see anything there that really makes me concerned. I think what's kind of a solid conclusion that having QTL3 is really important and having QTL6 is important. The fact that there's really no difference between 3 and 3, 6, and 10 makes me think that I would probably concentrate, on 3 and 3 and 6 initially. And by concentrate, I mean drive those QTL through marker-assisted selection into maize germplasm adapted to Africa. So this is just a general interpretation, and I don't think we need to dwell on it. The Agricola package supports both the design and the analysis of the alpha lattice experiment. The treatment means are adjusted to correct for effects across the incomplete blocks. Okay, and the intra-block analysis assumes that all treatments are fixed effects.